Ever wondered how the future of space transportation might look like? Is it going to be the same rocket launches we've seen, or can we expect something more advanced? As we stand on the cusp of a new era in space exploration, these questions have never been more pertinent. Space transportation, the method by which we send satellites, probes, and even humans into the cosmos, is a key component of our advancing civilization. For decades, we've relied on rocket launches, powerful, dramatic, and undeniably impressive. But they are also expensive, resource-intensive, and fraught with risks. The thirst for exploring the universe, however, remains undiminished. We continue to reach for the stars, to unravel the mysteries of the cosmos, and to expand the boundaries of human knowledge and experience. But what if there was a more efficient, cost-effective way to reach the stars? Enter the concept of space elevators. So, what exactly is a space elevator? Well, think of it as a super tall tower, stretching from the surface of the Earth all the way into space. Imagine a ribbon of material, anchored to the ground and extending upwards over 22,000 miles into the geostationary orbit. On this ribbon or cable run elevator cars powered by electricity, climbing steadily towards the stars. This concept, first popularized by science fiction, could revolutionize how we access space. Instead of relying on expensive and resource-intensive rocket launches, we could simply ride an elevator into orbit. It's a prospect that promises to slash the costs and risks of space travel, making the cosmos more accessible than ever before. But how would a space elevator work? The key is in the balance of forces. The downward pull of Earth's gravity would be countered by the upward centrifugal force from the Earth's rotation. These forces would hold the cable taut and stable, allowing elevator cars to climb it. Creating a space elevator is no small feat. It would require materials far stronger and lighter than anything we currently have. One promising candidate is carbon nanotubes, structures of carbon atoms, just a few nanometers in diameter, but with a strength over 100 times that of steel. The construction of a space elevator would also be a massive engineering challenge. Building a structure tens of thousands of miles high in the harsh environment of space is beyond our current capabilities. But advances in robotics and autonomous systems could make it possible in the future. A space elevator could be a game changer for space exploration. It could make sending humans and cargo to space as routine as catching a train, opening up new possibilities for scientific research, commercial ventures, and even space tourism. Sounds like science fiction, doesn't it? But could this concept become a reality? As we'll see in the next scenes, the answer might be closer than we think. The dream of a space elevator is a compelling vision of the future, one that could transform our relationship with the cosmos. Now let's talk dollars. How does the cost of using space elevators compare to our current methods of space transportation? Imagine you're planning a trip, but instead of flying, you're considering a more scenic route, say a road trip. Initially, the cost of gas, food, accommodation might seem daunting. However, when compared to the price of plane tickets, luggage fees, airport meals, and cab fares, the road trip starts to look a lot more appealing. That is essentially the comparison we're making here between space elevators and traditional rocket launches. Let's start with the rocket launches, our equivalent of the plane trip. The cost of sending just 1 pound of material into space using conventional rockets is around $10,000. This price includes the manufacturing of the rocket, the fuel, and the extensive and expensive safety precautions. Now consider that the International Space Station weighs nearly 1 million pounds. You do the math. On the other side of the equation, we have space elevators. The initial investment, like our hypothetical road trip, is significant. The cost of building a space elevator has been estimated to be in the ballpark of several $billion. However, the operating costs of a space elevator are expected to be substantially lower than traditional rockets. You can think of it as the difference between buying a car and paying for gas versus buying a plane ticket every time you want to travel. Beyond the initial construction, space elevators require minimal fuel to operate, and they could be powered by renewable energy sources. The cost per pound of lifting material into space could be reduced to as low as a few $100s, a significant drop from the current rates. Sure, the upfront costs are steep, but like any good investment, it's about the long-term return. The potential savings and increased accessibility to space could be immense. It may seem like a big investment now, but in the long run, space elevators could revolutionize our access to space. But it's not just about the cost. What about efficiency? let's dive into a comparative analysis of the efficiency of space elevators versus traditional methods of space transportation in terms of energy usage, time, and payload capacity. First, let's talk energy. Rockets consume massive amounts of fuel, not just to break free from Earth's gravity, but also to overcome air resistance in the atmosphere. Space elevators, on the other hand, would use electricity, and a lot less of it. The climb to space would be slower, yes, but it would be steady and unimpeded by atmospheric drag. Now, on to time. It's true that a rocket can reach the International Space Station in about 6 hours, while a space elevator might take several days. But let's look at the big picture. Rockets require meticulous planning and precise weather conditions. Delays are common. Space elevators, on the other hand, could operate continuously, regardless of weather, making them more reliable and predictable. And what about payload capacity? Today's rockets can only carry a small percentage of their total weight as payload. The rest is fuel and the vehicle itself. This limits the amount of scientific equipment, supplies, or personnel that can be sent to space in one go. Meanwhile, space elevators could allow us to transport larger payloads. Without the need for rocket fuel, the entire weight of the payload could be dedicated to useful cargo. This could be a game changer for space exploration and even for the possibility of space tourism. Of course, we're still a long way from building the first space elevator, but by examining these factors, we can see the potential for a more efficient, cost-effective, and sustainable future for space travel. In terms of efficiency, it's clear that space elevators could offer significant advantages. The concept of space elevators isn't without its challenges, though. Just as with any great leap forward, there are hurdles to overcome. Let's delve into some of these. First and foremost, we have the issue of material strength. To build a cable strong and light enough to withstand the enormous tension, we need materials far superior to anything we currently have. But don't lose hope just yet. The field of nanotechnology holds promise, with carbon nanotubes being a potential candidate. These tiny structures are incredibly strong and light, and while we're still figuring out how to manufacture them in the necessary lengths, advancements are being made every day. Next up, we have the challenge of power transmission. How do you power an elevator climbing thousands of miles into space? Traditional methods like electricity or fuel are impractical over such distances, yet here too we find potential solutions. Wireless energy transfer, where power is sent over distances without wires, could be an answer. It's a technology that's already in use today, albeit on a much smaller scale. The third challenge lies in dealing with space debris. Our planet is surrounded by a cloud of defunct satellites, spent rocket stages, and other debris that could potentially sever the elevator cable. To tackle this, we could use radar systems to track larger pieces of debris and move the elevator out of the way when necessary. However, the most daunting challenge could be the cost. Building a space elevator is an expensive endeavor, with estimates running into the trillions of dollars. But consider this. Once built, the cost of sending payloads to space could drop dramatically, making the initial investment worthwhile in the long run. And finally, there's the question of international cooperation. A project of this magnitude would likely require the collaboration of nations across the globe. Overcoming these challenges won't be easy, but the potential rewards could be astronomical. With every hurdle we clear, we're one step closer to a future where space isn't just for astronauts, but for all of us. So, where does this leave us in terms of the future of space transportation? As we've journeyed together through the concept of space elevators, we've discovered a future that's not just a flight of fancy, but a tangible possibility. From understanding the basics to examining its efficiency compared to current methods, we've seen how this game changer could truly revolutionize our journey into the cosmos. Space elevators have the potential to drastically reduce costs, making space exploration more accessible to a wider range of explorers. But like all great innovations, it comes with its own challenges. We've delved into these hurdles and even explored potential solutions, revealing a future that's within our grasp, should we reach for it. As we look ahead, let's imagine a world where the stars are just an elevator ride away, where the mysteries of the universe are not so distant. The journey to the stars may not always be a rocket ride. Perhaps one day we'll simply take the elevator.